few more people. Looks like we've got a few more people that have joined us here. Let's see here. How many people do we have? Always more than we can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is it 12? It seems like 12 is our magic number. Okay. Yep, don't know where the other people are, but thanks for coming. Okay, so let's start on 3.3, which is double and half angle identities. So what if your alpha equals your beta for the identities that we did previously? So find the sign of alpha plus beta, which in this case is really the sign of alpha plus alpha. So Texas, since we missed you last time, plus you're still on camera,
Yay.
Can you help us do the expand this out? Sine of alpha plus alpha
Would be the sine of alpha times the cosine of alpha plus cosine of alpha sine of alpha.
Okay. So we can add those two together, right?
Right.
So that becomes 2 sine alpha cosine alpha. Look what you just did, Texas. You just created a new identity.
Mic drop.
Okay. Mic drop. All right. So there we are. So there you are. The sine of 2 alpha equals 2 sine alpha cosine alpha. Okay. So that's your first identity to remember today for your double angle identity. So let's do the same thing. What if alpha equals beta? Find cosine alpha plus cosine alpha. So Tate, it must be your turn. Can you do the same thing that Texas just did?
So, hold on, what's the question?
I want you to find the cosine of alpha plus the cosine of alpha using the identities that we learned yesterday.
Okay, so it'd be cosine of alpha times the sine, no, that's sine. Cosine of alpha times the cosine of alpha minus the sine of alpha times the sine of alpha. Or 2 cosine alpha minus 2 sine alpha.
Okay. So there you are. You guys are 2 for 2. You've just, oops.
Isn't it cosine squared of alpha?
Oh, yeah.
Sine squared of alpha.
Oh,
Yeah, well, you distributed wrong, and I followed you. So yes, it should be cosine squared of alpha minus the sine squared of alpha.
thanks, Corey.
And so that is the cosine of 2 alpha right there. Okay, so there's your next one to remember. Now, also, we can implement the Pythagorean theorem, and so we can also write the cosine of 2 alpha equals 1 minus 2 sine squared of alpha, or 2 cosine squared of alpha minus 1. Okay? So those are some more things you'll want to memorize. Let's do the same thing with the tangent of alpha. So alpha equals beta again. So Nicole, it must be your turn.
Okay, I'm not gonna be as fast. So then would it be the tangent of alpha? Actually, I'm not totally sure on this one, I'll be honest.
Okay. Well, you're off to a good start.
It's the tangent of alpha plus the tangent of alpha.
Okay.
And then we divided by the tangent of beta over tangent of beta.
No, you might
Or
not have
so.
that one.
The 1 minus tangent alpha tangent. That's why I'm confused, because you have the alpha beta for that. Does it stay the same as the
Yeah.
identity? Or?
So it's 1 minus the tangent of alpha, tangent of beta, right? But beta's alpha.
Okay, so you just replace the beta with alpha. That's what
Right.
we're doing. Okay.
Right.
Okay.
Now,
gotcha.
can you simplify this numerator here?
Would you times it by the?
What's the tangent of alpha plus the tangent of alpha?
Oh, it's 2 tangent of alpha.
Tangent alpha. And what's 1 minus the tangent of alpha times the tangent of alpha?
1 minus 2 tangent alpha?
Nope.
Dang it.
Tangent times a tangent is?
Oh, tangent squared.
Tangent squared
Alpha.
of alpha. Okay. So, Nicole, do you feel pretty proud of yourself that you just created a new identity to memorize?
Yes. Thanks for your help.
All right. The tangent of 2 alpha equals 2 tangent alpha minus over 1 minus tangent squared of alpha. So you guys have all derived these, all Nicole, Texas, and Tate. Okay. So now you get to memorize them. Here you go. So these are known as our double angle identities. So the sine of 2 alpha equals 2 sine alpha cosine alpha. The cosine of 2 alpha equals the cosine squared of alpha minus the sine squared of alpha. It also equals 1 minus 2 sine squared of alpha, and it also equals 2 minus the cosine squared of alpha minus 1.
I don't get that part. Why is it equal to 1 minus 2 sine squared of alpha?
Okay, so good question. So you understand why cosine, why is that underlining? You do
Equals
understand why cosine of 2 alpha equals the cosine squared of alpha minus the sine squared of alpha, because we did that, right? You
Yeah.
understand that piece?
Yeah.
Now, you also remember that the sine squared of, I'm going to use a capital A, sine squared of alpha plus the cosine squared of alpha equals 1, right?
Yeah.
That's from the Pythagorean identity.
Pythagorean identities, right?
Yeah.
Okay, so now we can use this for either the sine squared, or the cosine squared. And so that's how you get these other two.
But how does the 2 get in front of the sine squared? That's what
Okay.
my question is.
So if I solve this for the cosine squared, that's going to be 1 minus the sine squared of alpha, right?
Yeah.
So I've got the cosine, I don't know why it's underlining. The cosine of 2 alpha equals, so we're substituting the cosine squared. So this is 1 minus the sine squared of alpha, right?
Yeah.
So that's just the first piece. Okay. Then we're subtracting the sine squared of alpha. So minus the sine squared of alpha minus the sine squared of alpha is minus 2 sine squared of alpha.
Okay.
If I get rid of my parentheses. So this is equals to 1 minus 2 sine squared of alpha. And so that's where we got this piece here.
So it just came from the cosine 2a. Like,
Say that again.
the 2 came from the 2 for the cosine 2a. I'm having a hard time understanding where the second sine
We're combining
squared
these
alpha
two
comes
right
from.
here.
Yeah.
So okay,
negative sine squared minus the negative sine squared is negative 2 sine squared.
Yeah. No, I
the one
understand that.
the one that's in the parentheses,
Uh-huh.
that's being substituted in for the cosine squared of alpha using the
Gotcha.
Pythagorean identity. Yeah.
Oh, okay. Okay.
Yeah.
I understand that.
Yeah,
Thank you.
we're throwing too many identities at you, huh?
Yeah, sometimes I just don't know where some of the things come from. It's just like,
Yeah. And so the 2 cosine works the same way.
it's the same way. Yeah. Okay, thank you.
Does that make sense?
Yeah.
All right. So now let's do another one here. Write the 4 sine 5 theta cosine 5 theta as a single trig function. So whose turn is it now? Nicole was next. So let's go to Mason.
Uh-oh. All
Mm,
right. So we want to write 4 sine.
And if you want, let's change that to x because I can't write thetas.
Yeah, that works.
So 4 sine
5x
cosine
cosine 5x.
5x. We want to write it as a single trig function. So just as a reminder, we've got our nice double angle identities there. Which of those 3 here does that look most like?
The top one.
Top one, right?
Yep.
If that was just a 2, it would be the top one, right?
Right.
Okay. Could we write that so that there's a 2 in the front of there?
Sure.
Sure, how?
All things are possible. We just have to divide it by. If we just divided the whole thing by 2, we could get 2 in the front.
Or we could factor out a 2.
Yeah. Factor
We
out.
could write it as 2 times 2 sine 5x cosine 5x, right?
Right.
And in fact, I'm going to put these in parentheses. Okay, now this piece looks just like our identity, right?
Yep. So that would
So
just
that
become
becomes-
sine of 2.
So that
Sine of
becomes
2 5x.
2 times 5x, right?
Right.
And I can't forget the 2 out in the front, right?
Yep.
So therefore, this becomes 2 sine of
10x.
10x. Bing! Don't you feel smarter now?
No, not really.
Not really. All right. Well, you should. That was good. You did well. Okay. So, and then if we put it in terms of theta, it's right back there. Okay. So now, let's do this one. If the sine of alpha equals 4/5 and alpha is in quadrant 1, find the sine of 2 alpha. Okay. So that was Mason. Mason, how come you're not on camera, by the way?
I still can't figure it out.
You still
I
can't?
think I might have to uninstall Teams and reinstall it. I think it's a permissions issue with my computer for some reason.
Google might help you. All right, Jackson,
It's,
how about you? You're not on camera either, Jackson.
Yes, I am. I can see myself on your screen.
How come I can't see you?
I can see him.
Oh, you can?
He's in the middle column, very bottom.
Oh, there you are. Oh, it's covering up. This thing's covering your face up. Okay, good. All right. So now, Jackson, what would you do on this problem?
Draw a graph.
All right, you're so good. I'm proud of you. Okay. We need a new graph here. We're going to do this. Don't save. Okay, draw a graph. Okay. I've taught you guys well, I can tell. Okay. So we've got a graph here. Slide it over a little bit. Okay, sine of 2 alpha. Okay, so if the sine of alpha is 4/5, we're in quadrant 1. So I'm just going to draw a diagonal line here. Okay, remind me again what sine again with in terms of x and y and r.
It is y over r.
Y over r. Okay, so in this case, y is going to be what?
Y is 4.
Y is going to be 4. And r is going to be
That's 5.
5. So this is nice because it's a nice 3, 4, 5 triangle, right?
Mm-hmm.
So therefore, your x is going to be 3. Okay, maybe I'll finish my triangle. Anyway, it's a 3, 4, 5 triangle. Okay. So, so if it's a 3, 4, 5 triangle, using one of these really cool identities here, what can we, which of these 3 identities looks most helpful?
So we're trying to find sine of 2a.
Right.
So I would say the top one.
The top one. So 2 sine alpha cosine alpha. Okay. So sine of 2a or 2 alpha equals 2 sine alpha. I'll capitalize it. Cosine alpha. Okay. And do we know those?
Yes.
So so we know that the sine of alpha equals 4/5 because we gave that to you. What's the cosine of alpha?
It's 3/5.
Cosine of alpha equals 3/5. So now we can just plug those both in, right?
Mm-hmm.
So this becomes 2 times
4/5.
4/5 times
3/5.
3. And can you do that in your head?
That's 24/25.
24/25. Bang. Who needs a calculator, you guys? You guys are all so smart. We're going to throw all your calculators away and we're going to call you all math magicians. Okay? All right. Okay, so there you are. Oh, there was another way to do that. I didn't even think of that. But I liked our way better. You could have also done the Pythagorean identity. Oh, I didn't think about that. So there's another way you could have done it. Okay. 4/5 plus the cosine squared of that minus 1, and then you could have found that. Oh, sorry, that was a different problem. I gave away the answer, though. We could have also found the cosine of alpha. So if we found the cosine of alpha, we can use the Pythagorean identity, and then we'd get 4/5 squared plus cosine squared of alpha equals 1. Cosine of alpha equals the square root of that. I like the way we did it better with drawing the picture and finding the 3/5 ourselves, but there's another way to find it. Okay. All right, so here's another one. Verify the cosecant of 2 alpha equals 1/2 the tangent of alpha plus the cotangent of alpha. Okay. So whose turn is it now? It must be Graham's turn. Which side looks more
Okay.
complicated?
Yeah, a little bit.
Well, which side looks more complicated, the left side or the right side?
The right side.
The right side. So if we're verifying an identity, we like to take the more complicated side. So let's go with the right side. So how could you rewrite the right side?
You could distribute that 1/2.
I probably wouldn't yet.
Okay. Could you rewrite the tangent and the cotangent as their
Right.
inverses?
So 1/2 times, how could you rewrite the tangent?
1 over the cotangent of alpha. Is that what
That's
you're...
true, but that's not what I was thinking of.
Okay.
You know what? I think I'm going to do this one in Excel because it's going to be a little bit easier. It's going to line up better.
You could do, are you saying do it over like sine over cosine, sine alpha over cosine alpha?
Yes, that's what I was thinking. Okay, so I've got my 1/2, and then we're going to write this as the sine of alpha over the cosine of alpha plus
The cosine of alpha over the sine of alpha.
sine of alpha. Okay, these are still in parentheses. Okay, so now what would you do next?
Would you distribute that 1/2 yet?
I wouldn't. Let's keep that 1/2 alone. We'll save that for later.
I'm not exactly sure.
Well, we got two fractions here, right?
Uh-huh. So do you get a common denominator so you can add them together?
Denominator. Okay. And the common denominator is going to be what?
Cosine alpha times sine of alpha.
Okay. So you'd multiply this side by what?
Cosine of alpha.
You've already got a cosine of alpha. You'd multiply this side by sine of alpha.
Sine of alpha.
Okay. So sine of alpha over the sine of alpha. So sine of alpha times the sine of alpha is what?
Sine squared alpha.
Sine squared of alpha. Okay. Now, what would you multiply this by to get your denominator?
Cosine of alpha.
Cosines, yeah. So now, so this becomes plus the cosine squared of alpha, right?
Yeah.
Okay. So what's the sine squared of alpha plus the cosine squared of alpha?
Just 1, right?
1. Bang. How about that? Okay, so now we've still got our 1/2 out in front here. We've got 1 over the cosine of alpha sine of alpha. Now, let me ask you something. Well, what would you do next?
You could split up. Could you split up the cosine and the sine?
No, but what have you wanted to do with that 1/2? That I've been telling you not to do. Let's distribute it now.
Okay.
So 1 times 1 is 1. And on the bottom, we've got 2 cosine alpha sine of alpha. Ah. My gosh, is that okay? It worked. Okay, so now, what does your denominator look suspiciously like?
One of the identities. I can't remember which one.
Yeah, let's go back and look at the identities. So, because I know you haven't memorized them yet.
Sine of 2 alpha. Well,
So
sine 2 alpha.
Sine of 2 alpha, right? So this, this equals, go away. Equals 1 over the sine of 2 alpha. Okay. What's 1 over the sine?
Cosecant.
It is the cosecant of 2 alpha. So we just proved or verified that answer, that identity. Cosecant of 2 alpha equals the cosecant of 2 alpha. Bang. Don't you feel smart now?
Getting there.
All right, you should. Okay. That was not a fun one. I mean, you kept wanting to distribute this, and then when I wanted you to, you didn't.
Yep.
All right. So well done, Graham. Let's see here. All right. So there we are. Power reducing identities. Okay. So these are some more that you're going to want to memorize here. So the sine squared of alpha equals 1 minus the cosine of 2 alpha over 2. The cosine squared equals 1 plus the cosine of 2 alpha over 2. And the tangent squared equals the sine over the cosine, essentially. 1 minus cosine of 2 alpha over 1 plus the cosine of 2 alpha. Okay, so let's derive the third identity here, okay? So the tangent squared of alpha, what could that be? Let's see, we just picked on Graham. Corey, it's your turn.
That could be sine squared of alpha over cosine squared of alpha.
I'm going to use a capital A for alpha over the cosine squared. I wonder if this is going to be easier to do in Excel. Let's do it in Excel. Tangent squared of alpha, just like you said, is the sine squared of alpha over the cosine squared of alpha. Okay. All right. Now, I know you haven't quite memorized all these yet, but do any of these look useful?
The cosine of 2 alpha. Or no, sorry. The tangent of 2 alpha? I don't know. I mean, the power reducing identities look a lot more like you could use them at least.
Yeah, they actually would be much better, wouldn't they? Okay, so let's use these. They're going to be a lot easier for this one. Okay. So the sine squared of, here, can I see these at the same time? Yeah, that's pretty good. Okay, so we're using the power reducing. So we can reduce sine squared of alpha to be what?
The one minus cosine of 2 alpha over 2.
And then the other one?
1 plus the cosine of 2 alpha over 2.
Okay. So, whoops, that's supposed to be a 2. So now we're going to flip these. The 2's are going to cancel. And we've just got 1 minus the cosine of 2 alpha over 1 plus the cosine of 2 alpha. So we did that. That was pretty easy. In fact, that's probably a much easier way to see it. Does that make sense? Okay. All right, write the sine to the fourth of theta in terms of a single power of 1 or more cosine identities. Okay. So that was Clifford, or no, Corey Clifford. Chris, it must be your turn.
Yep.
So we'll just change that to an X because I can't make thetas very well.
Yeah.
So what do you think?
Are we trying to change it into those?
What'd you say?
What are we trying to change it? I don't understand what.
We're trying to
one or more
change
cosine
sine to the
identities?
fourth into a bunch of cosine identities.
Okay.
So which of these three up here do you think would be most useful?
Would be the sine squared.
Right. So we could write this as the sine squared of x quantity squared, right?
Yeah.
The sine of 2x, sine squared of x, okay? So how do you rewrite the sine squared of x with one of these?
You could do 1 minus cosine 2a over 2.
1 cosine of 2x over 2. Okay,
All
so
of
this
that
is your
squared.
fraction. That whole thing squared. This is when it gets really hard to write up here. Okay, so that whole thing raised to the second power. Okay.
Gotcha.
Now, if we're squaring the 2 on the bottom, whoops, so this is going to become a 4 on the bottom, right?
Correct.
And then can you foil out the top?
Let's see, so that'd be 1 times 1 is 1, and then 1 times negative cosine 2a is negative cosine 2a, so then that would be the 2 of those, and then let's see, and then cosine squared 2a.
Okay, so this whole thing divided by 4. Okay, so you've written sine to the 4th in terms of a bunch of cosines.
Weird.
Okay.
Okay.
All right, and then this will look a lot better here. Oh, and then actually, as we think about this, I guess we were kind of done, but we can also write this term here in terms of, so if we want to get rid of the squared, we can do the same thing again, and that's going to become 1 plus the cosine of 4 alpha, 4 theta. That's supposed to be a theta.
Yeah.
Fix my notes here. All over 2. And we can simplify the whole thing again. So we're going to get 1/8 3 minus 4 so cosine of 2 theta plus the cosine of 4 theta.
Cool.
Okay. So the nice thing is we're able to get rid of all the powers, sine to the 4th, to just power of 1, essentially. Okay. All right. So let's talk about half angle identities. Now, I think somebody wrote me something here. Let me just see.
Yeah, that was me. So like, since you were saying you have issues writing out like thetas and whatnot, that uses the ASCII table to get your Greek letters in.
I'm impressed, but I'll have to check that out maybe after class. All right. Okay, and by the way, I was really impressed. Did I mention that? I think I did. On the test, some of you put all the Greek letters and square root symbols in on your test. Way too much work, if you ask me, but yeah, it's good. All right, so let's talk about half angle identities. Okay, so we've done, so far we've been dealing with double angle identities and power reducing. So we've got half angle identities now. So the sine of alpha over 2 is the plus or minus square root of 1 minus the cosine of alpha over 2. Now, you have to decide whether the plus or minus depends on which quadrant the alpha over 2 is. So it could be plus, it could be minus. So it just depends on which quadrant you're in. So that works with all of these. Cosine of alpha over 2 equals the plus or minus square root of 1 plus the cosine of alpha over 2. The tangent is plus or minus 1 minus cosine of alpha over 1 plus the cosine of alpha. You can kind of see in this case, these are just the square roots of all these, essentially. So yeah, I know you guys don't have enough to memorize. Let me just let's go back here. Okay, we've got our double angle identities to memorize. We've got our power reducing to memorize, and we have our half angle identities to memorize. So this is a tough class for memorization because we've got way too much to memorize. But anyway, that is what it is. Okay, so find the exact value of the cosine of 105 degrees. Okay, so we're trying to do this without a calculator. Okay, so we know that the cosine of 210 degrees, because that's a 30-degree angle past 180, right? So we know that that's negative square root of 3 over 2. Okay, so we can use, so I've got the half angle identities written again here. 105 degrees is in quadrant 2. Cosine is negative in that quadrant. So we can use this value here in our thing. So the cosine of 105 degrees is the negative cosine of alpha over 2. Okay? We know that, I don't know why I wrote that so many times, but anyway, 1 plus the negative square root of 3 over 2 over 2. When we simplify that, that becomes 2 minus the square root of 3 over 2 times 1/2, or the negative square root of 2 minus the square root of 3 all over 2. Okay? So on the next test, when I'm asking you to find the cosine of 105, I'm going to expect that you don't do it with a calculator, and you're going to give me this answer here. Does that make sense?
Will you ask us if you want us to use like half angle identities, or if you want us just to like do like what we did yesterday with like cosine of 60 plus the cosine of 45? Will you like have us differentiate just so we can?
Oh,
like,
I guess
show
there's
both
more than
ways,
one way to
or-
do this, isn't there? Yeah.
Because the first thing I thought of was 60 plus 45 of cosine.
Yeah,
Or
I would
cosine of 60
probably.
plus 45.
Yeah, I would ask you to use the half angle identity on this one. So
Okay, perfect.
yeah, because that's a good point. There's more than one way to do this. So yeah. Okay. Somebody's leaving me a note here. Let's see what the note says. Oh, same question with Brian. Yep. So I think I answered that. Okay, so let's do this one here. If the sine of alpha is negative 3/5 and it's between 180 and 270, find the exact value of the cosine of alpha over 2. Okay, so I'm going to copy this because we can probably use, oops, I didn't need to copy that. I just want this. Okay, so here we go. Now that I've got that there, now whose turn is it? It must be, we just picked Chris. Cassie, it's your turn. So Cassie, can you help me find the exact value without a calculator of this?
I can try.
Okay. And I will help you succeed.
So I want to start off by drawing a graph, right?
Very good. I am so proud of you for saying that. Okay, so this time here, let's just pick a different color. Like red. We'll use our same graph. Which quadrant are we in this time? Can you tell based on this?
Quadrant 3.
We're in quadrant 3. Well done. Except for that sounded like a question. That was supposed to be an answer. All right, quadrant 3. Here we are. So, and 3/5. This is going to be another nice 3, 4, 5 triangle, isn't it? Now we know that sine is y over r. So is y positive or negative 3?
Negative 3. Or
Whoops.
yeah.
Are you sure? Look at my graph.
Sorry, y is.
Oh, you're right. Sorry, I'm confused. Don't let me mess you up. So this is going to be negative. So this is going to be negative 3. Maybe I'll do it this way. This is going to be negative 3. Your x is going to be what?
5.
No, your hypotenuse is 5.
Sure. 4.
4. Okay, well done. All right, so we've got that here. Okay, so now what would be the cosine of alpha in this case?
It would be 4.
4 over
2.
2.
Or sorry.
Remind me what cosine is. Do you remember? I've got here sine. Sine is y over r. What's cosine?
Opposite over hypotenuse.
It's adjacent over the hypotenuse. Or in this case, x over r. Do you remember that? That was on our last test, but you'll definitely need to remember that. So cosine of alpha in this case is going to be remember, this is my alpha here. So adjacent is going to be this number here, which is did we lose your voice?
Sorry, my internet disconnected for a minute.
Oh, I was like, wow, yeah. Okay, so this is, do you see that this is 4 over 5?
Yes, I do.
Okay.
Negative.
All right, so
My screen hasn't caught up, but I know it's 4 over 5.
Okay. Oh, I'm sorry. That's a bummer. Okay, so we're using this formula here, and we have to decide in quadrant 3, is the cosine positive or negative?
Negative.
It's negative. So we're going to use the negative here. So this is going to be the negative square root of 1 plus, it says the cosine of alpha, and the cosine of alpha in this case is
4/5.
4/5 all over, here, I'll write this, all over 2. Okay, so we're done. Bring that up here. All right, so oh, I forgot to square that. So yeah, it's actually, if you do that, you're going to end up with the negative square root of 16 over 25, which is negative 4/5. Okay. All right. Oh, actually, yeah, I'm going to follow. Let me make sure. Okay. Why am I getting, oh, you know what, this is easier. It's easier to see here. We've got it here. 1 minus 4/5 over 2. So when we simplify that, that's 1/5 times 1/2, which ends up being the negative square root of 10 over 10. Okay. All right, let's move on to the next one. The tangent of alpha over 2 How much more? Oh, we're almost done. I think that's supposed to say tangent. Okay. So the tangent of alpha over 2, okay, let's try not to give you guys the answer here, but here's what we're going to do. I'm going to copy this. We've got 3 choices for the tangent here. All right, so I've got 3 choices for the tangent. Now, let's go back to our graph here, because we've got here the sine. Didn't we give us the sine? Yeah, the sine of alpha was -3/5. Sine of alpha is -3/5. The cosine we figured out was there. We could also figure out the tangent. Let's figure out the tangent just for fun. Tangent of alpha. Okay, so we just picked on Cassie, so whose turn is it now? Cameron Daly, it's your turn. So, so based on my red triangle here, Cameron, what is the tangent of alpha?
It would be +3/4.
It would be 3/4, opposite over adjacent. Perfect. Okay, so we've got the sine, the cosine, and the tangent. Now, let's go down to here. Hopefully I can see all those. Okay, so I can see everything there. So we want to find the tangent of alpha over 2. So you could use any one of those 3 formulas. Which one do you want to pick?
It don't do the second one. Or the third one?
The second one here, the sine of alpha over 1 plus the cosine of alpha?
Yeah.
Okay. Now, let me make sure I've got that right before I steer you guys wrong. That one's nice because we don't have to worry about the square root, does it? Yeah. Okay, so if we did that, okay, so the sine of alpha is what again?
It's -3/5.
So -3/5. We're going to divide that by 1 plus the cosine of alpha, and the cosine of alpha was?
-4/5.
Is it negative or positive? Yeah, you're right. It is negative. -4/5. Okay. So essentially, this becomes -3/5 divided by 1/5, right?
Yeah.
And then if you do the math there, the 5s are going to cancel, right?
Yeah.
And you're going to be left with?
It's -3.
-3. Bang. Okay. So, well done. -3 right there. Okay. All right. So let's do one more. Well, actually, we're about out of time. Tell you what. Who are we letting off the hook today? That was Cameron. Brody and Brian, we're letting you off the hook today because we've only got 2 minutes left. Okay, we want to verify 2 times the cosecant of x times the cosine squared of x over 2 equals the sine of x over 1 minus the cosine of x. So we're going to start with the left side because it's more complicated. So we can write this as 2 times the cosecant, and then we can use our half angle formula to write that as 1 plus the cosine of x over 2. Okay? And then, so we can simplify this. Remember, cosecant is 1 over the sine of x. So the 2's are going to cancel. This 2 will cancel that too. The cosecant becomes 1 over the sine, and I've got 1 plus the cosine of x over the sine of x. Okay? So I've now simplified this to be, now we've gotten rid of all the powers, okay? Now we want to multiply by the conjugate of the numerator this time, okay? So the conjugate of the numerator is going to be 1 minus the cosine of x, okay? So we're going to multiply 1 plus the cosine of x times 1 minus the cosine of x. So that becomes 1 minus the cosine of x squared over the sine of x times 1 minus the cosine of x, okay? So we've got that there. Now we know that 1 minus the cosine squared of x equals the sine squared of x, because that's just our Pythagorean theorem identity. One of this sine will cancel one of these sines, and I'm left with the sine of x over 1 minus the cosine of x, which is what I was supposed to verify. Okay. So we're done. All right, so in summary, the things that you're definitely going to have to memorize in this, your double angle identities, your power reducing identities, and your half angle identities. So, and I want you to know that it's not just me, that's the math department wants you to memorize these. So you will use these in calculus. So for those of you moving on to calculus, which I think is everybody, don't forget these ever. So any questions that you guys have for me?
So on, which one was it? One of the ones we did, I just got lost when, oh, it was the cosine one. So negative square root of 1 minus 4/5 over 2. How does that simplify down to the answer? I just got a little lost when you were explaining it.
Okay, so this is 1 minus 4/5, which is really 1/5.
Mm-hmm.
Divided by 2, we could say the same thing as multiplying by a half.
Okay.
So 1/5 times 1/2 is 1/10. If I rationalize the denominator, that becomes the negative square root of 10 over 10.
Just because, okay. Because when you're square rooting the entire fraction, are you square rooting both? Like you could break it up and say I'm square rooting the numerator and the denominator.
Well, yeah, the square root of 1 is 1.
Okay. Right. Okay, that makes sense.
Yeah.
Okay, thank you.
No problem. Any other questions? Well, we lost somebody. All right, no problem. So quiz tomorrow is on 3.3, and homework will be on that as well. So is there a note here?
I do have one quick question. As far
Okay.
as the homework, where it says multiples of 3 from 54 to 90, is that like 54, 57, 60?
Correct.
Okay.
Anything else?
That's it.
Okay. All right, well, we'll see you all tomorrow, and I'll get this stuff posted as soon as I can. Stick around for Texas and the study group if you want to. I'm assuming you guys are still having it, right? Okay. Cool. Well, I will stop recording now. See y'all tomorrow.
See ya.
All right, thank you.
Mm-hmm.